Okay, in this video, we're going to be talking about the basics of calculating and graphing motion. All right, so let's start off with velocity graphs. So velocity is a measurement of distance over time. And what we have here is an object changing by, it looks like 10 meters per second every second. And you can see the dots going up in a straight line here in a steady velocity. And this would be an object, since it's moving in the positive direction, would be would have a positive velocity. And here's the very opposite. So you have an object where every second it's changing by 10 meters per second downward, it looks like on the graph, and it's moving 10 meters closer to the origin every second, which would indicate a negative velocity, or a velocity in the opposite direction. Okay, and finally, if I have an object that is staying as a straight line on the graph, or it's not changing its position second by second, this is an object that's standing still, or it has no velocity. Okay, how do I find velocity? So I'm going to use this equation down here, the velocity equation. So it is the change in distance divided by the change in time. The delta, or the little triangle symbol here, is a symbol for change. So the change in distance divided by the change in time. So I can just take any two values here. Let's just take the first two, and I'll have 15 meters minus 5 meters. That would indicate the change in distance of 10 meters divided by 2 seconds minus 1 second, which would give me the change in time, and that would work out to 10 meters per second change, or 10 meters per second velocity. Moving on to acceleration. So in acceleration graph, you're going to have velocity over time, or meters per second over seconds. And what I have right here, very similar to velocity, if I have an upward trend in acceleration, this would be something that has a positive acceleration. So it's getting faster, moving in the positive direction. Similarly, if I have a graph that's trending downward, so I'm moving from 5 meters per second to 4 meters per second to 3 meters per second, this would be an object that has a negative acceleration, or an acceleration in the opposite direction. Okay, and now I have an object that is moving the same speed constantly. This is not an object that's standing still because it's moving at 3 meters per second, but it is not changing speed, so it has no acceleration. Finally, how do I calculate acceleration? Very similar to calculating velocity, except I'm taking the change in velocity, or delta v, over delta t. So calculating it really quick, the change from these two would be 3 meters per second minus 2 meters per second over 2 seconds minus 1 second. So that would just be 1 over 1, or a 1 meter per second squared change, or a 1 meter per second change.